Hi guys. Okay, so we're talking about cooling systems in class there, or online I guess you could say, and I got my 2009 Montana. It's a V6 as you can see. So I just want to go over a few things that we can see under the hood here to help give you a better understanding of what we're talking about. So we'll try to go over as many of the major components as we can. Some of them you can't see because of the design here. Some vehicles, you open the hood and everything is wide open. Other vehicles, not so much. This is a V6. It's a little bit bigger of an engine, so it takes up a little bit more room. So a lot of the components I want to talk about we can see. But for example, if this was a little four-cylinder engine, a smaller engine, we'd be able to see a lot more. But this one is pretty good. I'm outside because there's a car in the shop behind me here. So I'm going to do this outside, but it shouldn't take too long. So first off, you can see the pressure cap right here. Okay, this is the coolant pressure cap. So right now my engine is hot because I've been driving, and I don't want to take that off because if I do, we're going to have pressurized coolant come bursting out at me. You can see that this cap is rated at 18 psi. So what happens as the temperature of the engine heats up, the coolant, heats up. As the coolant heats up, the pressure in the system builds. Okay, and if it builds too much, like we mentioned, something is gonna let go, and we're gonna have either a hose is gonna burst, or we're gonna have some type of problem, and that can be an issue if we're stuck on the highway, in the middle of the summer or something, in rush hour traffic, and then all hell breaks loose. Okay, so as the pressure builds up, this cap, as I mentioned, is rated for 18 psi. You can say here it says never open hot, and read owner's manual for service and so on. Okay, so when the pressure in the system reaches 18 psi, what the cap does underneath, you can see how it's fastened to this neck right here, which goes on to this part of the engine assembly. This is part of the front. It's actually a coolant crossover, but we're looking at the front of the engine right here. So when the pressure reaches 18 and builds beyond 18, the cap actually inside, it releases, it lifts off of its seat, okay? And it allows that pressurized coolant to go through this overflow hose right here. And if we follow this hose, it goes all the way along to right here, and here's the other end of the hose right here, and this is my overflow jug. So you can see my coolant level is down here. This probably needs a top up. Somewhere on this jug here, there is a minimum and a maximum line. So the coolant, the hot pressurized coolant, will leave the cooling system of the engine, and it will get stored into the overflow jug. And then as the pressure starts to reduce below 18 psi, the coolant cap will actually close. Let's see what happens. I'm going to do this very slowly because I don't want the pressurized hot coolant to burst out on me. So I'm going to listen as well for any hissing noise that would indicate pressure is being released. Then I have to be really careful. Plus, I don't want to make a mess on my friend's driveway here. So I'm slowly going to unscrew this cap. And I'm just going to look to see if I see any hot coolant come out, and then I'm gonna give up on it and tighten the cap back because I don't want to make a mess, and I don't want to get hot coolant on me right now. So I'm just wiggling. I got it pretty much unscrewed. I'm just wiggling to see if there's any pressure in there. It's been shut off for about 15 minutes. So even though I can feel there's heat, it's still hot. Well, it's warm. I can leave my hand on it. It's not going to burn, but I guess the pressure has relieved itself enough that I can pull this cap off. So there is the cap there. That's what it looks like. Okay, and you can see the coolant inside here. And I'm going to put the cap back on because some of the coolant looks like is coming from so some is starting to leak out. So anyway, so inside the cap, that silver plate in there, it works against spring pressure, okay? And as the pressure builds, it pushes that round it kind of looks like a washer down in there underneath my thumb. And it pushes that back against the spring pressure, and there's a little hole that's there, and that hole allows the coolant to leave out of the hose here. Okay, so I'm going to put the cap back on. And that was the coolant that you saw in there. I'm going to put a piece of cardboard. Hold on. Because I don't want to make a mess. Okay, so that's the rad cap there. That's the overflow hose right there. That goes to the overflow jug. That's right there. Okay, so we'll put the hose back in. You can see that's the official identification of the cooling system. So a lot of times on your information cluster, you will have that symbol show up if there's a problem with the cooling system. Okay, so we'll move on to some other components. The radiator is located, you can just see it down in there, okay, behind my grill here. So the radiator is located at the front of the vehicle, so that way we get some air passing through it to help cool it down. And the coolant travels through the upper radiator hose, which is right here. Okay, this hose right here, and you can see how it has this clamp to hold it onto the neck of the housing right here. So the hot coolant will leave the engine, and it will travel through this hose. There it is down there. And it will go into the radiator somewhere under here. You can't see it under all this stuff. It's right there anyway. Okay, so you can see where it's clamped onto the neck of the radiator. So the hot coolant will travel through the rad. It will cool down as it passes through the rad. And down there is my lower radiator hose. And then it will return to the engine through that lower radiator hose, which is located just behind the water pump. And this water pump, you can barely see it, is that pulley right there. You can see that pulley right there that is driven by this serpentine belt is the water pump. So that water pump circulates and it just forces the coolant through the engine. Okay, and then the other component that you can't see is the thermostat. And I'll go inside. I'm sure we have a thermostat kicking around, and I'll show you what a thermostat looks like. And a thermostat is essentially it acts like a door, and it opens and closes based on the temperature of the coolant to either allow the hot coolant into the radiator to cool down, and then as the coolant cools down, the thermostat will slowly close, and it maintains a certain temperature, whatever the thermostat for that vehicle is rated at. Like I said, usually about 180 degrees Fahrenheit or so. Okay, so some more hoses. You can see these two pipes right here. So these two pipes go to these are coolant pipes. Okay, if we follow these two coolant pipes, they go down, they go under there, and then there they are right here. Okay, there's one there, and there's the other one there. And if we follow those hoses, they go right there. You can see the top one, and you can just see the one underneath it. Those are the heater hoses, and those hoses take the hot coolant from the engine to the heater core. Okay, so if we had a customer complaint of poor heat, which is common this time of year in the winter, the first few things that go to my head, obviously the first questions I ask them are year, make, and model of the vehicle and how many kilometers are on it, because kilometers are going to play a factor into kind of doing a diagnosis over the phone. If it's got 150,000 kilometers versus 40,000 kilometers, there's a lot more possibilities of faulty components with a vehicle that is 150,000 kilometers. So it's important to know that. And also the type of vehicle, because a lot of vehicles have their own particular problems. So if I have this guy calls me, or whoever calls me and says I have poor heat, it's let's say for argument's sake, it's a 2009 Montana 3.9 V6, 130,000 kilometers. The first few things that are going to go through my head are coolant level. Okay, so we can check the level in the reservoir, but we also want to check the level inside the cooling system underneath the radiator cap. Okay, so is the level up? Because if the level is low, then it's going to lose its ability to provide heat to the heater core, which is located on the other side of the firewall there. Okay, so coolant level is one thing I would think of if somebody's complaining of poor heat. The other thing is the thermostat. If the thermostat is stuck in the open position, then that coolant is not going to be allowed to circulate just through the engine to heat up. It's always going to be traveling through the radiator and staying cool. And that's not good, especially on a colder day like this. And as the temperature gets even colder, if that thermostat is stuck open all the time, then that coolant is going to take a long time if it gets hot at all. If it's allowed to circulate through the rad to cool down and back into the engine, it might not get hot at all depending on how cold of a day it is. Okay, so the thermostat is another thing I would think of for a complaint of poor heat. And the other thing I can check for is the temperature of these hoses here. Okay, so I'll try and shine this light so you can kind of see. So I would check the temperature of these hoses. So if I put my hand on this hose and I compare the temperature to the hose underneath it, they should be about the same. Because remember, one of these hoses carries the coolant to the heater core and the other hose returns it back to the engine. So there will be some heat loss, which is what we want as the hot coolant travels through the heater core and that fan is blowing the heat off it. There is going to be some heat loss, but the hoses should be pretty close to the same temperature. So if I put my hand on this hose, and we obviously have to do this when it's hot, okay, because we're checking for the temperature of the hose. We want a hot hose going into the heater core, and we want a hose that's almost the same temperature coming out. If one of the hoses is really hot and the other one is cool, then that means the coolant is not flowing through the heater core, and that means we probably have a plugged heater core, which is not that uncommon. To unplug a heater core, we just put a garden hose with a nozzle into the neck of the heater core, and we force pressurized water through the system to unplug it, because the passages that the coolant travels through in the heater core are very small and they are prone to plugging up. Okay, so those are a few things that I would think of or check for if we have a complaint of poor heat. Compare the temperature of the heater hoses. Check for the level of the coolant. We want to do that here. We can check here, but really we want to check, the proper way to check the level is here. We have to make sure obviously the engine is cold. You could see that mine was full, so that's good. And the other thing, if we don't see any problems, then we would replace the thermostat. You don't really take a thermostat out and check it. If you're taking it out, you're putting a new one in. So those are really the three most common complaints of poor heat. Okay, so I'm going to go inside. I'm going to show you a couple tools that we use to help us do inspections on the cooling system. But I think that's pretty much it for here. You can see that my vehicle is equipped with a temperature gauge. So that's the engine temperature right there. You can see how the needle is almost halfway. Okay, so my engine is warm. I can feel the warmth. Now remember, I removed the cap, which removes some of the pressure, which reduced some of the temperature. So if I switch my mode here to vent, it's still kind of warm. Okay, so if I wanted to get that hot really quick, what I would do is I would just hold my foot down. You can see my RPM gauge is up just over 2000 RPM. And as I do that, we can probably watch this temperature gauge. It might take a little bit longer than it's not really worth us sitting here trying to see it rise. Okay, no, we can't. I was hoping maybe I could see the temperature gauge rise, but that's not the case. Okay, so I can switch through this mode. I wonder if it's going to tell me engine temperature. No, it will not tell me engine. Sometimes when you scroll through when you scroll through your information here, some vehicles will tell you the temperature of the engine in a number form as opposed to a gauge form. Okay, so this is my gauge. This gauge is very important. The engine temperature gauge. A lot of them will have a red. they'll turn red as you get past 3/4, and that's to warn you, okay, that something is wrong. You do not want that gauge climbing. If I'm driving and I see my gauge go past half, I'm going to start to keep my eye on it. Okay, if it getting to 3/4, that's telling me something is really wrong. You do not want to overheat your engine. Those components are made of aluminum, and you can do serious damage. So if you're driving and you see that gauge, you can see it's climbed up a bit just from us sitting here. It's a little closer to half than it was a couple minutes ago. Okay, so that's a very important gauge for you guys to keep an eye on when you're driving. If you see it get up past half, you got to start to keep your eye on it. If it gets up, 2/3 or 3/4 of the way, something's wrong. Okay, and usually once they get just past 3/4, a lot of the gauges will have red lines, and that's just to warn you, something is wrong. You got to pull over. Like I mentioned yesterday, the other thing we can do is we can crank our heat. Okay, so I have my gauge set all the way to hot. I have my fan on full blast, and what that is doing is that is forcing that fan full speed to blow heat off of the heater core, and that will help reduce the engine temperature enough for maybe you to get to a gas station. But if you see that gauge continue to climb, you have to shut that engine off. You will do serious damage if you overheat your engine. Okay, one other thing I just want to show you is some vehicles are also equipped with a warning light, and this one is not. I do not see an engine temperature warning light, so really I would have to keep my eye on that gauge if I suspected there was any problems. Because as I mentioned, some engineers will program a warning light to come on, and maybe a bing, 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 okay, to warn you of any cooling system issues.
What do you want to do? You're checking coolant?
Yeah, I'm going to check the coolants. Okay, so this is a Volkswagen now inside the shop that I just came into. I want to show you a couple things we can do to check the cooling system. So let's say you're driving and you notice your gauge gets really hot. You see smoke coming from under the hood. You pull over, you open the hood, you see a clamp has come loose and a hose is leaking. You fix it on the side of the road, but you've lost a lot of coolant. So what you can do is you can fill it with water. You just need some type of a liquid to circulate to help take the heat away, okay? So we can use water, but as we talked about, water will create rust, and also think about the boiling point. The boiling point of water is a lot lower than the boiling point of coolant. So we have to, and also, sorry, that's not what I meant to say. What I meant to say is the freezing point. The freezing point of water is a lot lower than the freezing point of coolant, not boiling. Okay, so we don't want that water that's in our cooling system to freeze on a really cold morning. So we have here a temperature. This will test at what temperature the coolant will freeze at. So it's just like a turkey baster. We have this round bulb here, this rubber bulb, and you can see there's a needle in there, right there. Okay, and you can see the gauge here. It's kind of hard for you to see. There we go. There you can see. You can see the temperature. So if we put this in the cooling system like this, I suck some out like this. And we hold it like this, we can see that the needle is way up here and it's well above, I don't know if we can catch it in the light. Yeah, you can see the needle is up there. So if we were down about minus, you can see the red line, minus 30 is below, there's minus 10.
15.
Yeah, so the lower we are, we have to watch out, because that means that the freezing point of the coolant is lower. So usually about minus 30 or so is as low as we want to get. Anything below minus 30, we have to watch out, because temperatures here get to that range. So we would want to flush it and put the proper mixture of coolant and water. You can see the heater hoses right there on this vehicle are a lot easier to get to. There's a little 4-cylinder, so we have a lot more room back there. Okay, so now you get yourself home, you fill it with water, you fix the little leak that you had on the side of the road. If that's not possible and you continue to have a leak, we have to find out where it comes from. So I'll ask you this. Do you think the cooling system is more likely to leak when it's under pressure, or when it's not under pressure. Think of an easy question, but think of a balloon. Is a balloon, if it has a pinhole, you're going to notice the pinhole when there's air in the balloon or when there's no air in the balloon, or your bike tire, same idea. We have a lot of rubber hoses, we have gaskets, water pumps, and so on, lots of different places that can leak. So we have here a pressure tester, okay, and we can use this to pressurize the cooling system to show us if there's any leaks. So what we do is we would screw this down onto the radiator where the cap fastens to. We would lock it down. And hold on a sec, Frank. You can see the different adapters here for different design systems. Okay, so all these different adapters for Hondas, GMs, Fords, Volkswagens, they all are different just to make our life more difficult. And then what we would do is we'd lock the cap. We would lock this down on where the rad cap would go, and we would pump it up just like that. And we would pressurize the cooling system, and we would watch this needle. And remember, I told you that cooling systems, this one doesn't have a number on it, but mine, for example, was 18 psi. So we would pressurize the system to duplicate that. So I don't know if you can see on here those numbers. We would go up into that black area there. Okay, 15 to 17, we probably wouldn't have to go that high. Anywhere about 15 psi, you pressurize it. Okay, then what's going to happen is all the hoses are going to get really hard. Okay, and then we would look for a coolant leak. Okay, so that is a pressure tester. So those are a couple tools we can use to help us diagnose any type of coolant issues. And I think that's about it. Okay, so we're back to mine. A couple of important things I almost forgot to talk about was the cooling fans. So there is a fan here, and there is a fan there. It's a big fan, almost like you'd have in your house, sort of. You know, like one of those white ones that reciprocate, you put in your bedroom. Okay, so those fans will come on when the engine reaches a certain temperature. So if you ever walk in front of a car, if you're ever in your car on a hot summer day, and you hear that whoo, that is these fans kicking on. And what those fans do is they blow the heat off of the radiator. They remove that heat. Remember, the radiator is a heat transfer device. Yeah, you can shut it, Frank. Okay, so I am looking right now for my temperature sensor, but I can't find it. It is down there. And the temperature sensor is just a sensor. There it is, right there. You can see that electrical wire down there. And it is screwed into my cylinder head right into a coolant jacket. And that sensor reads the temperature of the coolant, and it tells the computer. And that is also how we get our gauge to operate. The gauge sometimes the gauge will use a separate sensor than the computer. Okay, but that is what we would call the ECT, the electronic coolant temperature sensor, or the engine temperature sensor, ETS or CTS, coolant temp sensor, different names, but essentially that sensor tells the computer the temperature of the coolant, and that computer uses that information to turn the fans on. It uses that information for fuel delivery, because remember, a cold engine is going to use a bit more fuel, and so on, that we talked about. Okay, so I think now that sums up pretty much everything that I can show you about the cooling system. All manufacturers use their engineers use their different design, but they all essentially serve the same purpose and use the same components. Another tool that we use is this pyrometer here. This is a laser temperature gun. So if we want to check the temperature of different components, you can see the laser there. Okay, so if we wanted to check the heater hoses, that one is 21.2 and that one is 21.2. This engine is cold, but this is an easy way, instead of using our hands. I like to use hands, it's kind of old school, but if you can't get to the hoses, you can use this laser here to check the temperature of that hose. Then you could compare it to the temperature of that hose. Okay, we can check the temperature of the radiator if we can see it, and to make sure it's cooling, because we should have temperature reduction as the hot coolant travels through the rad. So this is a good little tool to have. It's called a pyrometer. I think it's called a pyrometer. Yeah, I think it's called a pyrometer. Okay, and it's just a laser temperature gun.